4. Federated or consortium blockchain. This is a conglomeration of privileged participants on equal footing who are pre-selected. This is unlike a public blockchain network absent access control and free for all. Therefore, as a less decentralized semi-private network not open to all, more performant than a public blockchain, and has the ability to enable consensus building among independent organizations, all of its privileged, verified peer nodes determine and agree on the consortium blockchain network consensus rules. This network also requires no token or cryptocurrency, as financial incentivization is not its fundamental existence purpose. The network enables adaptability, as consensus rules can be changed according to the equity to the entity or group of entities benefit. As a high-speed network, a federated blockchain is suitable for public sector and private sector organizations use alike. Offers include a certain degree of cryptographic auditability attachment. Power does not reside within a single system authority, but operates under group leadership. Not everyone with internet connection has transaction verification, participation process access. Faster network that provides higher scalability and transaction privacy. Examples: IBM blockchain, R3 Corda, Quorum, Hyperledger. etc. Federated blockchains ecosystem diagram. IBM R3 Corda, Voltron powered by R3 Corda, BBVA, Rangbok Bank, Mizuho, ING, and the rest. IBM powered by Batavia, powered by IBM, UBS, Kaiser Bank, Commerce Bank, etc. Uno blockchain source, Uno blockchain data source. 4. The blockchain trilemma. The blockchain trilemma is the popular technological assumption that no blockchain could be secure, decentralized, and scalable at the same time, as blockchain could only provide two of three benefits at any given time with respect to security, decentralization, and scalability. It is essential that this trilemma is false, as the blockchain would neither sacrifice decentralization nor security nor scalability. The scalability trilemma diagram. Scalability A. Security Pick one side of the triangle. B. Decentralization. Uh, C. Security. A. Scalability. B. Decentralization. C. Security. Source: Medium. The blockchain trilemma: scalability, security, decentralization. How many transactions? The diagram. How many transactions per second? TPS bracket. Scalability: multi-chain ecosystem, decentralized, traditional chains BTC. Secure, are resistant to attacks. Typical ITPS chains: Solana, Binance Chain. How many nodes are they concentrated in center of power? VRoom.co, blockchain data source. Blockchain security. For blockchain network throughput increase purposes, node distribution must be decreased geographically or numerically, or both. Decentralization pivot reduces proof of work (POW) network security efficiency. 51% attack execution chances on an open network with limited nodal distribution is quite possible, as hackers could without much ado acquire requisite mining hash power for 51% attack, overwhelming the network with sufficient and controlling hash power. Hackers can hijack the network and thus carry out network manipulation for malicious financial interest gains. Ethereum blockchain fork, Ethereum Classic, etc., had fallen victim to 351% attacks. Blockchain security is a must have which cannot become compromised and ubiquitous for any distributed ledger network worth its salt. 3. Decentralization. Though the blockchain is distributed inherently, each node hosts a ledger copy bracket. Inherent decentralization does not exist. The centralization or decentralization question depends on any specific ledger design choice consideration involving participants' rights that cut across access, decision-making powers, obligations, etc. Public blockchains are inherently decentralized notwithstanding, and decentralization therefore is their central ethical data point. However, optimal ledger decentralization has lower transaction throughput. But this trade-off improved stability, optimal service levels. There is also another distributed ledger widespread adoption impossibility trade-off as a result of optimal decentralization. More so, decentralization can be a gradual process where management access and other rights are devolved to the nodes and miners within the network over time. Diagram: centralized, decentralized, and distributed. Scalability: the ability of a blockchain platform to achieve high transactional throughput and future growth without significant transaction fee increase and without performance sacrifice. When a blockchain performs badly, consequent upon usage growth, such a blockchain lacks scalability. Though there is greater blockchain scalability, feasibility, security, or decentralization, or both security and decentralization would suffer as a consequence. According to the blockchain trilemma principle, blockchain technology platforms are solving or attempting to solve decentralization, security, and scalability issues through layer 1 and 2 solutions. 5. Blockchain technology solution layers. Layer 1 solution, main architecture upgrade, sense addition overlaying, i.e., consensus mechanism change, sharding brackets used on Silica, Tezos, Qterm, and proposed to be used by Ethereum 2.0, chain splitting, etc. Layer 1 platforms diagram: Waves, Symbol, Polkadot, Stellar, Neo, Dash, Bitcoin, Cosmos, Tron, EOS, Cardano. Source: blockchain.comparison, blockchain-comparison.com. B. Layer 2 solution. This is a secondary framework protocol solution influenced by or built on top of existing blockchain distributed ledger technology with its own working mechanisms and particularities and ability to achieve transaction high throughput without sacrificing network security. Its aim and objectives are to solve 1. Blockchain scaling bottlenecks, 2. Transaction throughput, 3. And settlement speed issues, etc. Examples: Lightning Network payment channel, Ethereum Plasma sidechain, rollups, etc. C. Other Ethereum blockchain layer 2 solutions diagram. Arbitrum DYDX. Name Arbitrum DYDX. Optimum Loopring. Metis Andromeda. Baba Network. ZK Sync. ZK Space. Immutable X. Diversify. Total value locked. Arbitrum $3.16 billion. Extra. Breakdown. 7-day change. Market share. Purpose. Technology. Optimistic roll-up. ZK roll-up. Optimistic roll-up. ZK roll-up. Optimistic chain. Optimistic roll-up. ZK roll-up. ZK roll-up. Validium. Source. The Defiant.io. Blockchain layer solutions. Blockchain layers solutions 1 and 2 key differences. Criteria, distribution, layer 1, scaling solutions are modifications in the protocol of the blockchain. In the base layer, protocol, in the base protocol of the blockchain networks to achieve improved scalability. Layer 2. Scaling solutions involve the use of off-chain services or networks to improve scalability. Criteria working. Layer 1. Changes in the base protocol, such as larger stock sizes, larger block sizes, and new consensus mechanisms, can empower scalability. Layer 2. Sharing the transactions, ordering, and processing workload with off-chain solutions improves scalability. Types. Layer 1. Consensus protocol improvements, sharding, modifications in block size. Layer 2. Hashed blockchains, sidechains, state channels. Source 101blockchains.com. 6. Blockchain layers and use cases. There are different blockchain transaction layers and different use cases emerging and developing in various sectors. Below, Microsoft Azure blockchain cloud ecosystem graphic layouts provides minimal Bird's eye view. Microsoft Azure diagram. Use cases, decentralized diagram is not clear. 2. Services layer. Involves services such as transaction, digital identity management, KYC management, digital asset wallet, currency conversion. 3. Smart contracts layer consists of the programmable pieces of code that enable the program running. 4. Blockchain agnostic core layer is the underlying blockchain is the underlying main chain protocol network, which consists of nodes, etc., exemplified by Bitcoin, Ethereum, Ripple, Corda, etc. 5. In general, the blockchain layers are detailed in the graphic illustration here below. Infographic. One, application layer, which consists of programmable currency, blockchain 1.0, Bitcoin, Ethereum, etc., programmable finance, blockchain 2.0, intelligent contract, staking, etc., programmable society, blockchain 3.0, IoT, AI, DAO, etc. 2. Contract layer, which consists of script code, code, algorithm, mechanism, intelligent contract, intelligent contract. Three, incentive layer, which consists of issuance mechanism. Rewards are generated from mining and handling fees are obtained from package transaction. Allocation mechanism. 4. Consensus layer, which consists of POW, electric energy consumption, mass computing. POS fights for the right to record according to the number of tokens and holding time. DPoS generation of bookkeeper through community elections. Network layer 4. 5. Network layer, which consists of P2P network, communication mechanism, a node, broadcast messages within the P2P network, and other nodes verification mechanism. 6. Data layer, which consists of data block, chain structure, block, 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 timestamp, microtree, microtree, transaction hash number sequence scattered right under the blocks bracket, digital signature, hash function, SHA-256. Use cases: decentralized apps, currency, banking, payment system, currency exchange, remittances, peer-to-peer marketplaces, fundraising, trade finance, bracket entire financial services industry gamut, cross-border trade and commerce, insurance, supply chain management or finance, real estate, government, security, digital ownership, logistics, voting, energy, IoT, healthcare, gaming, prediction markets, tokenization, big data, etc. Note: more blockchain and distributed ledger use cases are still emerging. Seven. Gartner's Blockchain Hype Cycle 2022. Oh god, it's not clear at all. Diagram: expectations, metaverse, innovation trigger, peak of expectation, throw of disillusionment, slow of enlightenment, plateau of productivity, time to plateau will be reacted 2 years, 2 to 5 years, 5 to 10 years, metaverse, 10 years, Web3 Oracle Layer 2, Zero Knowledge Proofs, Enhanced Blockchain as a Service, CDFI or CDEX, decentralized autonomous organization. Decentralized exchanges, decentralized identity, NFT, blockchain, and IoT, tokenization, stable coins, further reading, source links. All relevant content sources duly acknowledged.